So in this video, I'll explain how to simplify radicals. So the first thing that we need to unpack, it's like, what is a radical? Or the first question we need to answer is that what is a radical? So normally what we know from some laws of radicals is that you have square root of a is equals to, what is this? Can also be represented by 2 root of a, and then this is also equals to a to the power 1 over 2. That's a basic radical that maybe you can know. And then another common radical or common radical law is that when you have n represent and then a, this can be represented as a to the power 1 over n. And then another quick one is when you have n root of a to the m. So this, it's more like the same thing, just different way of representing it, but this is the main one. So you have a, so this is your inside exponent and then your index, so you call the n the index, so this becomes a to the power of the exponent over the index. So you can explain it like that. You can explain it like this is the exponent, and then this is the index. Or one way to explain this or to know this law is saying a to the power inside, you have the inside over the outside. So that's something, or that's a simpler way to understand this. So let's get into examples and get to unpack this with examples that will help you to sort of like understand how this thing works. So let's do examples on this. So let's say you have 3 root of 8, right? And then we want to simplify this, right? So take your calculator. On your calculator, punch 8 and then put equal sign and then press shift, then press the button fact, and then it will give you that this is the same as 8 can be represented as 2 to the power of 3. And then what do we know? There's a law that says if you have n root of a to the power n, this is equals to what? It's equals to a. And then maybe to unpack this further, this is the same as a to the power of n to the power 1 over n. This becomes a to the power of n over n, which is just a to the 1, which is just a. So in this case, our answer would be just 2, right? So you get to learn this by doing more problems or getting more practice on this, and I think the more you do more problems, is the better you become, or the better you understand this. So okay, let's take it a bit further, right? Let's say you have cube root of 625, right? You have cube root of 625. Then do the same thing. Take your calculator, using Casio calculator. So press 625 equal sign, and then press shift, and then press the button fact. It will give you it will give you cube root of 5 to the 4. But we want to simplify, so we want to make this 4 to be a 3. So another law that you know, or that you can relate this, is that you know that a to the you know that a to the n multiplied by a to the m, it's equals to a to the n plus m. So you know this law, right? And then there's also a law that says n root of ab, it's equals to n root of a and root of b. You can separate it, right? So that's the two laws that you're going to use. So in order to simplify this, we'll first break what is inside the cube root. It would do to be 5 to the 3 multiplied by 5 to the 1. So we just work backward, and then we got that. And then what does this equals to? This equals to what does this equals to? So what can we do here? We can break it down. Let's break it down. This is 3 root of 5 to the 3, and then 3 root of 5 to the 1. So let's erase this. And then what does this become? What is 5 to the 3? Root of 3, using that the law up there, it was it this law? and then it gives us 5, and then this is just 3 root of 5. Okay, quite interesting. So this is another way of simplifying logs when you have was it not logs, radicals when you have huge numbers inside. So yeah, forgive me for saying logs. I was doing logs not so long ago. So let's proceed. What happens now when you have something like this, right? Let's say you have cube root of 3 to r to the power of 20. I'm just loving cube root today, so just bear with me. But it can work. The moment you understand this method, you can deal with such problems with when you even have any other cube roots or any other number or another different types of index in there. So if you can understand this part, I think you can be able to maneuver through any other parts. So okay, in this case, what is the goal? We want to simplify this, right? We're simplifying. So we're simplifying. Don't forget the goal is to simplify. But in order to achieve the simplify, or in order to re-represent what we're given in its simplest form, what can we do? What can we do? So we need to change this. We know that 20 is not divisible by 3, right? So 20 divisible by 3? No. But and then let's minus 1 from 20, which is 19. Is 19 divisible by 3? No. And then but 18 is divisible by 3. So this we can change this to be r root of r to the 18 and then r to the 2, because we already know from laws of exponent that r to the 18 dot r to the 2 is equals to r to the 18 plus 2, which is just r to the 20. So we didn't change anything. We just represented it in a way that favors us to be able to simplify. So let's further simplify this problem. To further simplify this problem, it's cube root of r to the 18. We break it down, cube root of r to the 2, and then what happens here? What happens? This becomes what? This becomes r to the 18 over 2, and then this we can change it because 2 is not divisible by 3, so we can leave it like that. And then this becomes what? R to the 6, and then cube root of r to the 2. So this is one way to represent whatever we were given at the top in simpler form. So yeah. Okay, so let's get into the big part of the of this video. So what if now I say simplify, 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 and then you given what? What are you given? You given 3 cube root of minus 135 y to the 6 and p to the 11, right? P to the 11. So you're given that, right? So what is the first thing that we're going to do? Let's rewrite the problem and get to solve it. So you're given cube root of minus 135. Okay, let's actually break it down just to save time. Cube root, then that, and then we break it down. We're breaking it down. Cube root of y to the 6, cube root of p to the 11, right? So what can we do with the 135, right? So let's check on the calculator. 135 equals sign, shift, fact. It gives us something. It gives us 3 to the power 3 multiplied by 5. So in this case, we're going to have 3 cube root of 3 to the power 3 multiplied by 5. So, and then what is this? This is y. We're not worried about this because we know y to the power 6 divided by 3, it's 2. So we're not worried about that. But we're worried about this p to the power 11. Why? Because the 11, it's not divisible by 3. So we need to break it down into something that it can be divisible by 3. How do we do that? So we know, we say 11 divided by, on your calculator, punch 11 divided by 3. It's not divisible. Reduce it to 10, and then it's not divisible. Reduce it to 9, and then 9 divided by 3 is divisible. So this is going to be p to the power, I think p to the power 9 multiplied by p to the power of 2, because we still know that what is this? We still know that p to the 9 multiplied by p to the 2 is the same as p to the 2 plus p to the 9 plus 2, which is just p to the 11. So we didn't change anything. What can we do further? We can now further say 3 cube root of 3 to the 3, and then cube root of 5, cube root of y to the 6, cube root of p to the 9, cube root of p to the 2. Right. So in this case, we are not, these two things cannot be simplified further, right? The others we can simplify further. So let's first simplify those we can simplify. Cube root of 3, this is just 3, and then y, and okay, maybe let's say 3 over 3, and then y to the 6 over 3, and then p to the 9 over 3, and then we have what's it? Okay, let me write them in blue. The ones circled. We have 3 root of 5, 3 root of p squared, right? And then what is this now? This gives us what? This is just 3, and then this is just y to the 2, this is just p to the 3, and then so we can rewrite this as what? As just allow me to erase, I'm just cleaning up the screen. We can represent this to be cube root of 5p to the 2, right? So this is how you get to solve this problem. So for those who are doing mathematical analysis at the University of Johannesburg, this could have been your A, and then the inside could what's inside here could have been your B, right? So yeah, this is how we solve this problem, and I hope you enjoyed it. Don't forget to like and subscribe, and yeah.